Hey guys, if you are new to the audio world, I want to explain to you how speakers are tested, or how manufacturers test the response of a loudspeaker that is designed. So what I did the other day, I did a few tests of some loudspeakers that I had, and I just wanted to see what the response would be of each loudspeaker. So I went ahead and test two models. So actually, what you see right here is a test that I did. I actually did a white noise test. So basically, I'm gonna explain what a white noise test is. It's a test, it's a sound that you hear like a shh. And you're probably familiar with that sound. You ever had, those old-fashioned TVs or those tube TVs, when a channel don't come in, it gives a hissing sound, or if the station is not in, it just shh. Well, basically, that's what a white noise test is. It gives you a response from 20,000 hertz all the way down to 20 hertz, and it's just a flat response, or a flat white noise, a hiss that goes from 20 to 20, and it's no peaks or no dips in it. It's just flat all the way across the sound spectrum. So basically, that's what a white noise is, white noise test. So I did one on this loudspeaker. This is called the MB1 loudspeaker. And after I did the white noise test, I was kind of surprised on the response of it. I wasn't too surprised, but the response looked pretty good. So I just want to explain to you guys, what to look for when you do actually what manufacturers look at when they do a white noise test, or when they test a loudspeaker to see how it sounds. So this is one I did. So to get to the graph, you click on Analyze and Plot Spectrum. And there we go. And then I'm going to enlarge it so you guys can see it. So basically, this is a white noise test of this loudspeaker. And from, looking at it, it looks pretty good. It's not that bad. So basically, this is what you look for. If you're doing a white noise test yourself, this is what you want to look for to start. And again, this is an MB1 loudspeaker, and it's a fairly mid-sized loudspeaker. It has a volume of 0.43 cubic feet, which is almost a half a cubic foot. And it has an 8-inch driver and a 3/4-inch V for tweeter, which is a very well-known tweeter that was used by many manufacturers, and it's very popular for its sound quality. So that's the tweeter that was used. And also, this is in a seal cabinet design, so there's no ports or no vents in the loudspeaker. Totally seal cabinet. So this is the response that I got when I measured this loudspeaker. So basically, when you're looking at this chart, what you're looking for is usually, by theory or on paper, most people look for a loudspeaker that has a flat response. And what I mean by flat response is that think of it as a ruler, that's flat. And if you was looking at this chart, and if everything in purple, as you see that there's a response in purple, but if everything in purple was perfectly flat, like a flat line like you see here, that would equal a flat response. But as you can see, there's a lot of peaks. These are like, they may look like hills to you, but these are actually called bumps and peaks and dips. So you see you have a bump right here, or bump right here in this region. And again, this speaker goes from what I see, from 50 hertz all the way up to 18,000 hertz. So when you're looking at this chart, as I said earlier, ideally a lot of manufacturers want their speakers to have a flat response. That is their goal. They think that, if you have a flat response to speaker, it's going to sound great. But in reality, on paper, it looks great. But in reality, it doesn't sound that great. Basically, a flat sounding loudspeaker does not sound really that good. And there's a reason for that. Because all the audio and instruments plays at a certain level when you're listening to music. So there's not really much of excitement to the music, because it's all playing at the same level. Ideally, the reason why you would want a flat sounding loudspeaker is the fact, if you're a musician or a composer or someone who works with music that does a lot of mixing and mastering, you will want your speakers to be flat, so your mixes would translate well into the loudspeakers or into the device that the music is playing through, like a pair of loudspeakers, clock radios, or even the speaker system in your car. You want it to sound good, right? So ideally, you would want to pair a pair of flat sounding studio monitors, and that's why a lot of engineers or audio engineers use studio monitors, because they give off a flat response. But again, that doesn't mean that they are considered, they are used for mixing only, not for playback. So ideally, that's what you want to use if you are monitoring audio, something that has a flat response, so you get a balance in the dialogue and the vocals and instruments to see how they really sound. But for playback, it's different. You want a speaker that sounds lively, that brings life into your music. So for casual listening or for playback mode, you will want a pair of speakers that are not so flat to get the most sound, or to get exciting sound from your music. But for monitoring and critical listening, engineering, you want a pair of flat speakers. So I hope I explained that well. I hope I explained it so you understand it. So that's what basically most manufacturers look for. But again, as I mentioned before, ideally, you want something that has a little bit of a bump to it, and it's okay if there's some peaks, as long as it's not too many peaks. But as you can see right here, this is basically where the woofer goes. It starts from 50 hertz and it goes all the way up, let's see, to about 3,000 hertz. And there's a peak right here. As you can see, this is a peak. Anytime you have a chart where there's a certain response that goes really high, as this one, these are what you call peaks right here. And there's dips, like this is a dip because it goes down, it goes up and down. So those are called peaks and dips in the audio spectrum. And again, this is just normal. There's nothing wrong with this loudspeaker. This is just normal. There's very few speakers out there on the market that has a perfectly flat response. There's some that do, but it's not that many. So this is just something normal. So to get rid of these peaks right here and these dips, you would have to, create a crossover design and add filters to remove these peaks, or just to flatten them out. That's a term they use, is flatten. You want to flatten these peaks out, so the speaker ideally would sound better if you do that. But again, this is a speaker that I was working on. I've been working on for a while, and to me it looks pretty good. And you can't really judge how a speaker sounds just by looking at a chart like this, or a response chart like this, because you have to listen to it with your ears to actually see how the speaker really sounds. Because even though if the chart looks like this, and this is pretty good from right here to right here, it looks pretty good. The only thing I don't like is these two peaks right here. But as you see, the lower bass is pretty smooth. Looks nice right here. But again, when you listen to this loudspeaker, it sounds really good, especially in the bass region. And even as treble region, which is up here, it still sounds really good. But again, this is why you need to listen to a loudspeaker instead of just looking at a chart to see how it's going to sound. The chart gives you an idea. Basically, it gives you all the peaks and the dips and the response level of the driver. So basically, that's what you want to look at, and this is what most people do. They want to look at the response of the drivers, not really the loudspeaker as a whole, but look at the drivers to see how they perform, in a cabinet or in a box. So, and this is what I look at basically, see how the drivers perform. And if the drivers don't perform the way I want them to perform, then I have to go in, and create a crossover that can flatten this out, or maybe even, increase the sound a little bit of the driver till I get it to sound the way I want it to sound. But this just gives you a really good idea. If you have any trouble, basically, if there's certain frequencies that are, that are really being brought out in the loudspeaker, or if it sounds a bit peaky, you could use this graph right here to analyze it. You can see where the peak is coming from, or where the noise in the driver is coming from. And this is why I use this chart in this software for. So so going back to the loudspeaker, the woofer, it looks really good right here. It's nice. It's pretty smooth with a couple of bumps, but again, speaker's gonna sound pretty good. So I'm not worried about that. And the peak, and this is the bass again. The peak or the bass goes from anywhere from 20 hertz all the way up to 200 hertz would be considered bass, and anything over 200 hertz or above would be considered mid bass. So from 250 to 400 hertz, which is right here. Let's see if I can put a chart, which is right here. It's considered mid bass right here. And bass would be considered from, again, low bass would be anything from 20 to 50 hertz. Bass would be 80 from 100 hertz, and so on. So the bass region looks really good. And again, I tested the speaker. I listened to it. It sounds good. Then as you go up, you get around 800 hertz. Now, so these are the lower mid-range. Anytime you go from, it depends how you look at it. Mid-range start at 500 hertz, somewhere right here. And then mid-range, the lower mid-range goes all the way up to maybe 800 hertz. So you got the lower mid-range. Then from 800 hertz, let's see, I would say anywhere from 1,000 hertz up to 3,000 hertz would be the mid-range section right here. And basically, this is what's really critical, believe it or not. Anytime you do mixes or you work with music, you typically go from 100 hertz up to 5,000 hertz when you do. Well, not everybody, but most people, when they do mixes, they mix in a range of 100 hertz up to 5,000 hertz, and some may go up more, but basically that's the range you want to be in when you do mixes. Okay. And this is why you see a lot of musicians, when they do mixes, and it's the difference between mixing and mastering, but when you do mixes, this is why you see them. They have these little cube speakers or little small speakers that they use to mix, like 6.5-inch drivers or even 5-inch drivers, because that's where all your critical listening is and all your music is. The critical instruments lies in that range, from 100 hertz up to 5,000 hertz. And again, anything beyond that, it's not really that critical. You can hear it, of course, but what they focus on is in that range. So that would be, that would be right here. That would be from right here, from 100 hertz all the way up to right here, 5,000 hertz. And that's why you would want to have a speaker that's flat, so you can see, basically how it sounds, to see if you need to bring down any other instruments or bring down any other vocals, or you want to raise the vocals or raise some of the instruments so it sounds balanced. And that's the whole point, where a lot of people compose music. They want the instruments and the vocals, they want everything to sound balanced, right? And they want to hear the vocals that mix well with the beat and the instruments. And that's another technique they use too, when it comes to creating music, writing music, or even creating lyrics to a beat. They basically sing or use the lyrics or sing the music according to the beat pattern of the song, so it blends in well. In order to hear that and to hear it very well, this is why you would want to use a pair of studio monitor speakers. So I'm getting off subject right now, so I'm going back to this response chart. And I'm sorry about the noise in the background. That's the heater coming on. So I'll try to make this really quick. But yeah, so basically the tweeter is right here. And I can see where the tweeter starts at, because the tweeter has a really big peak to it. As you see, it starts right about right here, which is 3,300 hertz. So this is where the tweeter starts, because I believe the woofer is 85 or 86 decibels in sensitivity or sound pressure level, while the tweeter has a sensitivity of 89 decibels. So that's like a 3 or 4 decibel difference, and this is why you see so much of a peak right here compared to this other region, because the tweeter is slightly louder than the woofer. And that's like that with all speakers. This is why you want to pad the tweeter down. Use resistors to pad it down, so it would play. So the tweeter would play at the same level as the woofer right here. And this is actually what I did on my second test. I padded the tweeter down, so I was able for this peak to go a bit down. It went down about 3 decibels, so it blended in better with the woofer. And by doing that, that will give you better sound quality. It will sound more balanced with both speakers play at the same level. It makes it sound balanced. So yeah. So what is next? As you can see, this tweeter, this is actually where the tweeter really sounds. Even from the manufacturer that measured these drivers, I got the same reading as the manufacturer. And this particular tweeter is not flat. It does not have a flat response, as you can see. There's a lot of peaks and dips right here. So, and that's the way the tweeter measures by the manufacturer too. So, but when you listen to it by ear, this is what I mean. When you listen to it by ear, it sounds totally different from where it looks on this graph. You know, again, it's a great sounding tweeter. You can't really hear all this. You know, you can't hear these dips right here. You can't. You just hear a tweeter that sounds. To me, it sounds balanced, but as you can see, it's not really balanced. And this is what I'm saying. You know, you can't really go too much by how a chart looks to tell actually how a speaker sound without listening. You have to listen to it also to hear how it really sounds. This chart right here is good to show you if you have any breakups, you know, in the loudspeaker, or any problems in the loudspeaker. You want to address those problems. This is the software. This is what you use to address those problems and fix those problems. If the two drivers are not communicating well with each other, this is what you use. This is the software right here, or the chart that you use to figure that out. And this is what I did, you know. So it really helps. But again, you know, it gives you the idea of how your speakers are tuned properly. So again, this is not really a bad response. You know, like I say, it's a little bit rough right here in the tweeter section. But, you know, again, when you listen to it by ear, you know, can't really tell it. But again, if you wanted to clean this up a little bit, you know, you would have to pad the tweeter down once. You know, that's the first thing you would do. Then you have to put some filters on it, you know, some notch filters to pad it down a little bit. Not to pad it down, but to clean it up a little bit. You know, to lower these peaks right here. And try to basically flatten out the sound of the tweeter. That's what you would do, you know. Same thing with the woofer. You want to flatten out the sound of the woofer. If there's some, you know, really bad peaks, I mean, like say right here, and you want to flatten this out, you have to put on some filters on the woofer to flatten that out. But again, this is not really that bad, especially right here. It looks pretty good. So yeah. I'm trying to think of if there's anything else that I need to mention. So again, this was just a test I was doing. I was really surprised by the test. And what really surprised me was I was using a different loudspeaker. I tested 2 loudspeakers. And I tested, actually 3. This is the third one, this MB1. But I tested 2 smaller monitors with 5-inch woofers. And I was really surprised by the bass response of these small woofers. I got a flat, I got just about almost a perfectly flat response from 50 hertz all the way up to 100 hertz on a 5-inch woofer in a very small cabinet. And I was surprised by that because it's such a small driver, a small cabinet, to be able to reproduce, you know, something that low, 50 hertz, and for it to be flat across that range. That was really impressive to me. And that's going to be in the next video. I'm going to show you next video how that came out. But again, this is a bigger speaker with an 8-inch driver. So it looks good. And again, the driver plays pretty smooth until it gets to, let's see, until it gets to about, I'll say about right here, 700. Right, well, let's see, 8. yeah, to about 900 cycles or 900 hertz. And that's when it begins to break up. And this is normal. And this is what I wanted to mention too. This is typically normal of an 8-inch driver. The higher you go, since the driver has a larger diaphragm, it's going to be more of a breakup because it's going into the mid-range. Usually large drivers are good for getting a lower response. It's good for bass, not so good for mid-range. So with a lot of 8-inch drivers, you got to see where it breaks up at. And it breaks up not that bad, but it breaks up around right here, which is around, I would say 1,000. Yeah, 1,000 hertz up to wherever it goes, up to 2,600 hertz. So it's almost 3,000 hertz. So this is why, you see a lot of crossover filters that cut the woofer off around right here. Usually they come off at 2,000 hertz below. Anything that's 2,000 hertz below, it will remove the breakup in that driver. So you won't hear it. The breakup will still be there, but it would filter out where the speaker breaks up at. So this is why you want to cross your speaker over below that breakup. So basically with this woofer, you might, if you don't want to have this peak right here and these dips, you might want to cross the woofer at I guess 900 right here, ideally 900 hertz. So that means you would have to use a mid-range driver instead of a tweeter. If you can find a tweeter that can be crossed over that low. And this is what a lot of manufacturers do. You kind of cut the driver off somewhere where it doesn't break up as much, so you get better sound quality. But again, it's kind of peaky, but it's okay, because I believe this driver is cut off right here. I believe it's cut off at 3,000 hertz, which is about right here. And this is where the tweeter come in, so you can see where it's cut off at right here. And this is another reason why you would want to use a chart like this to see where the drivers are cut off at and where they break up at. So I guess that's about it. So I just wanted to explain to you guys, if you're new to the audio world, you want to, if you want to know how, loudspeaker sounds, or how basically loudspeaker get their sounds and how they perform, this is what a lot of people do. They just do a white noise test to see how the two drivers are communicating with each other. So that's about it. And yes, I don't think there's anything else that I need to explain. I think I explained everything. So again, in the next video, I will do some more charts of compare, different loudspeakers, or even different cabinet designs, to see is there a different, response by using cabinets, different sizes, also with foam panels and without foam panels, to see if it's a difference in the response of the drivers. So I hope you enjoyed this video, and I will see you next time. Goodbye.